Hello friends, in this video we are going to discuss the series operation of SCR. Okay. So in the industrial applications where the load is having a higher voltage and the higher current rating, at that time a single SCR cannot withstand with that much of high voltage, right? So in order to share the voltage, whatever the voltage required, voltage rating of the load, in order to share that voltage we need to connect the number of SCRs in series. Okay. Similarly, the load is having the higher current rating, so due to that we need to connect the number of SCRs in parallel in order to share the rating current of the load. Okay, so first let us discuss the series operation of SCR. Okay, series operation of SCR. So suppose, so the first thing is why we need to connect the SCRs in series, in order to share the load, in order to share the load voltage. Okay, we need to connect the number of SCRs in series because a single SCR cannot withstand with that much of high voltage. Okay, so for example, suppose we are having the n number of SCRs connected in series, right? Suppose we are having n number of SCRs connected in series. This is thyristor T1, next T2, next T3, and so on. Okay, this is a Tn. So this is Tn, T3, T2, T1. Okay. So next, voltage across thyristor T1 is Vt1. Voltage across T2 is Vt2. Voltage across T3 is Vt3. And voltage across Tn is Vtn. Okay. So here we are having the n number of SCRs connected in series. Okay. So what is the total voltage of the string? It is a Vt1 plus Vt2 plus Vt3 dot 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 plus Vtn. Okay. So now related to this, yes, we are having the two factors. One is the string efficiency, and second one is the derating factor. Okay. So what is the string efficiency? String efficiency is the string voltage rating, that is a voltage rating of string divided by number of SCRs in series, number of SCRs in series, connected in series, into maximum of, yes, Vt1 to Vtn, Vt1 to Vtn. Okay, so which one is maximum from Vt1 to Vtn we need to select. Okay, so accordingly we can get the string efficiency. Okay, either it is a maximum of Vt1 to Vtn, or if they give the rated voltage of the SCR, and if all the SCRs are having the same rated voltage, okay, then at that time we need to put, yes, the rated voltage of a SCR. Okay, so next, derating factor is equal to 1 minus string efficiency. 1 minus string efficiency. This is nothing but the derating factor. Okay. Now, for example, suppose we are having the two SCRs. Okay, T1 and T2 are connected in series. For example, so suppose T1 and T2, these two are connected in series. We are having, this is a T1 and this is a T2, right? Suppose voltage shared by T1 when it is in series is Vt1, voltage across T2 Vt2, as both are connected in series. Okay, so therefore same current will be flowing through both the SCRs. Okay, now suppose SCRs are having the VI characteristics as shown in figure, right? So here voltage across SCR, current flowing through SCR. Okay, so suppose this is the VI characteristic of the first SCR, right? Next, suppose the VI characteristic of the second SCR. So this is the VI characteristic of second SCR. Okay, so this one is for first SCR and the blue one is for second SCR. Okay, now as the function or as the purpose of connection of SCRs in series is to withstand with high voltage. Okay, but when SCRs are in the on state, what is the voltage across the SCR? It will be, strictly speaking, it will be 0. Okay, but when SCR is in the off state, the voltage across SCR will be very high. Okay, so please be careful when SCRs are connected in series. At that time we need to concentrate on the forward blocking mode of SCR, right? Forward blocking mode of SCR, because suppose for particular application, okay, we need to maintain the open switch. Okay, means the current should not flow through the load. Okay, so whatever the supply voltage is there, the full supply voltage should be blocked by the number of SCRs. Okay, so full supply voltage, that is nothing but your string rated string voltage. Are you getting the point? Okay, so we need to concentrate on forward blocking mode of the SCR. Be careful, forward blocking mode of the SCR. Okay, so suppose SCRs T1 and T2 are connected in series. Okay, so suppose this much of current, that is, this is a leakage current only, this much of current is flowing into the circuit. Okay, so here this is cutting to the second SCR plot at this point. Okay, so suppose this is VT2 and this is VT1. Are you getting the point? Okay, so when VT1 and VT2, or when both the SCRs are having the different VI characteristics, then the voltage shared by the SCRs will be different. Okay, if both the SCRs are having the identical VI characteristics, then the voltage shared by the SCRs, yes, it will be same. Okay, so here what will the string efficiency? Yes, we can write it as string efficiency is equal to, string efficiency in this case is equal to, yes, it is a string voltage is VT1 plus VT2 divided by number of SCRs are 2 into what? Yes, out of these two, which one is maximum? It is a VT1. Okay, so this is the string efficiency. Okay, and what is the derating factor? 1 minus string efficiency is a derating factor. Are you getting the point? Okay, so we need to concentrate on forward blocking mode. Okay, when SCRs are connected in series. This is a very important point. Okay, why we are not concentrating on forward conduction mode? Because during the conduction mode, yes, SCRs are acting as a short circuit, so the full voltage yes will appear across the load. No need to think about the voltage across the SCR. Okay, means suppose we are having the circuit like supply, I am writing here. So suppose we are having the circuit like, here it is a supply voltage which is a high voltage. For example, I am considering it as a DC, and we are connecting the two SCRs, for example SCR1 and SCR2 in series, and here it is a load we are having. Whatever the supply voltage is there, this supply voltage is nothing but the rated voltage of the load. Okay, so when yes SCRs are in the off state, at that time only the voltage will be higher across the SCR. Yes or no? Because during the forward blocking mode, SCR is characterized with low current and high voltage. Okay, so when SCRs are in the off state, this voltage VT1 plus VT2 should be equal to Vs. When SCRs are in the on state, yes, these two will be acting as a short circuit, so load voltage is equal to Vs. Okay, so be careful when SCRs are in the on state, sorry, when SCRs are connected in series, at that time we need to concentrate on forward blocking mode, because SCR string should be able to block that much of voltage. For that we need to connect the SCRs in series. Are you getting the point? Okay, so this is about the series operation of SCR. Okay, for getting the 100% efficiency, yes, VT1 and VT2 should be same. Okay, if VT1 and VT2 should be same, then what should be the requirement? Yes, VI characteristics of both the SCRs should be same or should be identical. Okay, are you getting the point? Right, in the next video we are going to discuss the parallel operation of SCR. Thank you.